Here are the key points broken down. TCP/IP overview. TCP/IP protocols, designed to work together for end-to-end message transmission across interconnected networks. TCP, Transmission Control Protocol, operates at the transport layer. Ensures transparent data transfer between end systems using lower network layer services. Responsible for establishing connections, error-free data delivery, and maintaining the order of data. Differentiates between applications on the same device. IP, Internet Protocol, operates at the network layer. Handles data sending and receiving in blocks. Determines the best route for data packets, but does not guarantee delivery. Purpose. Both TCP and IP work together to ensure data is transmitted efficiently and correctly across a network. TCP/IP Protocol Stack. Protocol stack layers. Each layer depends on the services of the layer below it, with the highest level of communication at the top. 1. Application layer. Manages high-level protocols for representation, coding, and dialogue control. Handles application-related processes and prepares data for the transport layer. Examples: Telnet, File Transfer Protocol, FTP. Simple Mail Transfer Protocol, SMTP. 2. Transport layer. Manages quality of service, reliability, flow control, and error correction. TCP provides reliable, connection-oriented communication. UDP, User Datagram Protocol, is connectionless and provides data transfer without guarantees. Example protocols: TCP, connection-oriented; UDP, non-connection-oriented. 3. Network layer. Responsible for routing packets from source to destination across networks. Ensures packets reach their destination regardless of the route. 4. Network access layer, host-to-host layer. Includes LAN and WAN protocols and the physical and data link layers from the OSI model, also known as the link layer or data link layer. Interfaces with network hardware. Here are the key points broken down. IP protocol. Importance. IP is the most crucial protocol at the network layer. Nature. Non-connection oriented and does not guarantee reliability. Limitations. Does not provide reliability, flow control, or error recovery. These functions are managed by transport layer, with TCP provides reliability and error recovery. Application layer, with UDP handles any necessary error control. Message unit, the basic unit of information in an IP network is an IP datagram. Application layer. Function, handles user interaction with the computer and services. Example, browsers, e.g., Google Chrome, Mozilla Firefox, Internet Explorer, Opera, operate at this layer, even without the TCP/IP stack installed. Protocol interaction. HTTP protocol, used for initiating queries for remote documents. Role. The browser interacts with the application layer, which serves as an interface between user applications and the protocol stack, facilitating communication through the lower layers. Responsibilities. Identifying and establishing communication availability with the target destination. Determining resources needed for communication. Key protocols of the application layer. FTP, File Transfer Protocol. HTTP, Hypertext Transfer Protocol. POP3, Post Office Protocol version 3. IMAP, Internet Message Access Protocol. SMTP, Simple Mail Transfer Protocol. SNMP, Simple Network Management Protocol. Telnet, TCP/IP Terminal Emulation Protocol. Here are the key points broken down. UDP, User Datagram Protocol. Non-connection oriented. Unidirectional data flow from sender to recipient. No acknowledgement from the recipient. No sender information transmission. Recipient only knows the sender's IP address. Properties. Unreliable. No packet retransmission or error correction. Not ordered. No guarantee of packet order. Datagrams. Integrity checked individually. No overall delivery guarantee. Lightweight and speed. Direct data transmission without error recovery, suitable for applications where speed is crucial, such as streaming audio or video. TCP, Transmission Control Protocol. Connection-oriented. Recipient acknowledges data receipt. Error checking and correction. Uses CRC, cyclic redundancy check, to verify data integrity. Allows retransmission of corrupted data. Role in TCP/IP model. Main Transport Layer Protocol. Manages data from lower levels. Uses IP datagrams with a protocol field set to 6, TCP. Connection management. Controls transmission status between two communicating machines. Can create connections for data flow between programs on different computers. Can create connections for data flow between programs on different computers. Properties. Reliable. Manages message retransmission for lost packets. Ordered. Ensures data packets are delivered in the correct order. Heavyweight. Establishes connections via a three-way handshake, SYN, ACK, before data transmission. Here are the key points broken down. IP addresses. Definition. Uniquely identify a device over the Internet. Types. Public IP address. Assigned to a device when it connects to the Internet. Private IP address. Used within an internal network. IPv4 and IPv6. IPv4, limited address space, 4,294,967,296 addresses. IPv6, larger address space, 340 undecillion addresses, to accommodate more devices. Ports. Definition, numerical values, 0 to 65,535, used to identify communication endpoints in an OS. Function. Identify processes that communicate over a network. Each process uses a unique port to send and receive data. Common ports. 22. Secure Shell, SSH. 23. Telnet Remote Login Service. 25. Simple Mail Transfer Protocol, SMTP. 53. Domain Name System, DNS Service. 80. Hypertext Transfer Protocol, HTTP. 443. Hypertext Transfer Protocol Secure, HTTPS. Example, URL http://www.domain.com 8080/path/ specifies port 8080 instead of default port 80. Public versus private IP addresses. Private IP ranges. 192.168, 0 to 192.168, 255, 255, 172.16, 0 to 172.31, 255, 255, 10, 0 to 10, 255, 255, 255. Public IP address, assigned by Internet Service Providers, ISP. Finding IP addresses. Commands. Linux, IP address. Windows, IP protocol configuration all. Output, displays IP addresses assigned to network interfaces, e.g., ETH0 on Linux, Ethernet adapter local area connection on Windows. Loopback interface. Definition. Virtual interface for local device communication. Common name, localhost. IP address, usually assigned 127.0.0.1. Use, local network application testing and inter-process communication. Main difference between TCP and UDP. TCP, connection-oriented, allowing bidirectional data transmission after establishing a connection. UDP, simpler, connectionless protocol, facilitating faster packet exchange without needing a connection. Differences according to features. 1. Data transfer. TCP ensures orderly, reliable delivery of data between user and server. UDP, no point-to-point connections, does not verify data recipient availability. 2. Reliability. TCP, reliable, recognizes received messages and retransmits lost packets. UDP, unreliable, does not verify communication outcome, no connection checking or packet retransmission. 3. Connection. TCP, oriented towards congestion control and frame reliability. UDP, non-connection oriented, designed for rapid packet exchange without ensuring correct arrival. 4. Transfer method. TCP, reads data as a sequence, transmits messages in defined segments. UDP, sends individual data packets, verifying integrity only upon arrival. 5. Operation. TCP, establishes connections via a start and verification process, followed by data transfer and closes connection after completion. UDP, provides unreliable service. Data may arrive unordered, duplicated, or incomplete without sender or receiver notification. Assumes error checking is unnecessary. 6. Applications. TCP, used for error correction mechanisms, e.g., HTTP, HTTPS, FTP. UDP, used for applications with small requests from many clients, e.g., DNS, VoIP. IP address assignment. Static assignment, manually configured by a network administrator. Dynamic assignment, DHCP automatically allocated by a DHCP server when a device connects to a network. Dynamic Host Configuration Protocol, DHCP. Function, allocates IP addresses from a predefined pool, useful for networks with frequent device connections, e.g., public Wi-Fi, mobile networks. DHCP server, configured with IP address ranges, subnet masks, gateway, and server names. Responsible for assigning, leasing, reallocating, and renewing IP addresses. DHCP process. 1. Client request. Device issues a DHCP discover request via UDP broadcast when connecting to a network. 2. Server response. DHCP server assigns an IP address and other network parameters to the client for a set time. 3. Lease renewal. Client may request to renew the IP lease before it expires. Key points. DHCP discover. Client does not need pre-configured network interface to issue request. Subnet configuration. DHCP server can be on the same or different subnet. Without network configuration, client cannot reach other subnets. MAC address. Server may use client's MAC address to determine assigned IP. Lease management. Server grants network configuration for a limited time. Client must renew lease or stop using configuration after expiry. Making a DHCP request. 1. Clients. GNU/Linux, used client. Windows. Use IP protocol configuration/renew. 2. Function. Client uses network configuration obtained through DHCP.